Expo 2025 Osaka-Kansai, Japan has come at last, gathering numerous examples of the science and technology of the future. Here at RITE Mirai no Mori, from April 13th to October 13th, 2025, the New Energy and Industrial Technology Development Organization, NEDO, tested and exhibited a technology to collect and reuse carbon dioxide. NEDO is conducting this project as part of research for its Moonshot Goal 4, Recover the Global Environment. Here we see what the exhibit looked like. Those things lined up on the roof look like huge duck beaks. Are they equipment used in the experiments? They separate and capture from the air the CO2 that is generated by industrial facilities and scattered into the air. The CO2 is then sequestered in the earth and recycled as resources. This exhibit equipment makes it easy to understand and study this process. Now we go in and the big apparatus we saw from before appears again. Hello.
Konnichiwa.
What is this equipment?
This is an experimental version of a system called Direct Air Capture, DAC. We're working to develop it for commercial use. The purpose of the experimental apparatus is to capture CO2 from the air and either sequester it in the earth or reuse it as a resource.
Capturing CO2 directly from the air? Is that possible?
CO2 is a trace gas comprising 0.04% of the atmosphere. If we cup our hands and consider the amount of air contained in that space, the CO2 takes up about the space of a single grain of rice. Collecting that sparsely distributed CO2 will require unprecedented technologies and ideas.
So how do you capture that CO2 when it's so thinly distributed?
In our research project, we use amine as a material to absorb the CO2. We're exploring ways to raise the efficiency of that amine to make it practical to use amine to collect CO2 from the air. We're developing the equipment for that process and the various technologies that comprise it.
So DAC combines mechanical equipment with a chemical reaction with amine?
Right. Scientists in chemistry, engineering, and other fields are working together to develop this equipment and system. It is the completed version. It uses our original material, RITE amine. RITE amine is developed by this gentleman, researcher Katsunori Yogo.
This apparatus uses an amine that selectively captures CO2. It uses our original material, RITE amine. The amine can't be used as is, so we coat it with a honeycomb structure. With this arrangement, the amine can capture CO2 selectively from the air, even with air flowing through it at a high rate.
What makes RITE amine special?
RITE amine has two special properties. First, it releases CO2 in relatively cool steam of 60 degrees Celsius. Previously used amines were easily able to capture CO2, but releasing the CO2 afterwards required steam at temperatures of 100 degrees Celsius and hotter. Second, RITE amine features high resistance to oxidation degradation. As an organic chemical, amine deteriorates with exposure to oxygen in the air. RITE amine's resistance to oxidation degradation is significantly higher than those of commercially available amines.
A big step forward. We can see that advantage in operation here.
Yes, as you can see, the system is now collecting CO2 from the air, demonstrating the feasibility of the process. Fans are installed behind the apparatus. These fans draw air toward them through the system. Air is drawn through these open inlets. The box-like part at the back that reads direct air capture is filled with a CO2 absorbent that captures CO2 as air is blown through it. When the structure can no longer absorb CO2, valves behind and in front of it are shut. The CO2, which is heated and concentrated by steam from the piping, is then collected.
In the future, we hope to capture CO2 from the air using large-scale DAC facilities, such as the one shown in the panel behind us.
We're looking forward to it. Thank you. Hello. Look at this cute image of a polar bear. What is this exhibit?
We call this Cryo-DAC. This experimental device uses liquefied natural gas, LNG, stored in the extreme cold of minus 160 degrees Celsius to concentrate CO2 from the air. Our system uses liquid amine to absorb CO2 from the air. To remove the CO2 from the liquid in which it is absorbed, rather than heat the liquid to generate CO2 as in previous designs, we use the phenomenon by which liquid CO2 becomes solid dry ice under extreme cold, decompressing it without a pump. That's how this arrangement removes the CO2 from the amine. When natural gas at minus 160 degrees Celsius is released, the cold liquid becomes a gas, capturing the heat around it. This is the same principle as is used by spray cans. The liquid inside becomes gas, capturing heat from the ambient air and cooling it.
Earlier we heard about removing CO2 by heating it, but in this case you're cooling it. How is this arrangement useful?
Today, Japan imports 70 million metric tons of LNG per year. This LNG is gasified to serve as fuel for power stations and used as a feedstock in town gas. However, this phenomenon of capturing heat from surrounding air through gasification is not always effectively used. Our aim is to put this heating and cooling to good use by placing equipment nearby Japan's 40-odd LNG bases and using heating and cooling of the LNG stored there to collect CO2 at the lowest cost possible.
What an exciting prospect! Keep up the good work. This exhibit looks quite different. Hello! Is this device DAC too?
Yes, we call this one DAC-U for direct air capture and utilization. First, the device on the right is fitted with a membrane. The membrane is extremely thin, just 30 nanometers thick. This thinness makes the membrane extremely efficient at capturing CO2 from the air. The CO2 stripped from the air is stored in a tank. Later, the CO2 is moved here and converted.
Something like an air purifier?
Yes, like that. CO2 is stripped from the air, so it's like an air purifier.
What happens to the CO2 you've collected?
It might be used to make carbonated water, for example. But in our project, we expect to convert the CO2 chemically into useful carbon compounds such as methane.
I see. I noticed that this device is smaller than the big DAC exhibited outside.
That's right. Moves to process large volumes using large equipment are advancing worldwide. But since air is everywhere, we want to enable CO2 collection anywhere. Ultimately, we aim to create small devices that can even collect CO2 in the home. This is how we are exhibiting our vision of future changes in living at Expo 2025 Osaka, Kansai, Japan.
We've learned today that NEDO is tackling a wide range of solutions for future society, including new technologies such as DAC, as well as a wide variety of other approaches. DAC may well prove to be the trump card for recovering the Earth's environment. We encourage researchers everywhere to find their own practical solutions as soon as possible.
NEDO